All right, I'm gonna try to study my file counter program and try to fix what's wrong. So I wrote this on my Android tablet, and I'm gonna try to use my Windows path instead. All right, copy as path and put it here. Since we're on Windows, I'm just gonna use backticks. All right, let's try running this. See what we get. So we already have some issues. I don't even know what's going on. Well, let's just let's print some stuff. Let's just print running at the beginning. Cool. So this program is running. Let me print the entries. Let's print entries. What do we get? So we got something. So these are the entries. So these are the files, and we got some stuff going on here. So what am I doing here? Okay, so this is a file counter. So first, I am taking the path. I'm getting the directories and files from the path. And then I create two channels. I create two channels. Create two channels. I get a weight group. I start a Go routine, and I did not add any like. Okay, I get a. I get a weight group. I start a Go routine. I start a Go routine that loops over entries, and I start a Go routine that loops over entries and sends values to file channel or folder channel depending on the entry type. Okay, send to appropriate channels. So we have a go routine that const that checks for the counter to reach 0 and close all the channels. And then we have a infinite loop. And in an infinite loop, we I print the file name when I receive from the file channel, and when I get a folder in the folder channel, I process the folder. So this is pretty much it, right? I check if the channel is closed. If it is, I set the channel to nil, and I check if the channel is nil at the beginning of the loop, and exit from the loop. If the if all channels are nil. So the process channel takes a full path, and folder channel, and file channel, and wait group. Okay. Process folder takes full path, file channel, folder channel, and wait group. We read the directory, loop over the entries. We read the directory from the full path, send it to file channel if it's regular file, and send it to folder channel if it's folder. Okay. This is pretty much what we are doing. So the problem, what are the problem we have? Problem 1, I don't know how to use wait group. That's the problem. So normally how do you use weight group? Usually when you start a go routine, you add you increase the counter, and when you are done with the go routine, you decrease the counter. So where are we starting go routines? So this is the first initial go routine. So we start it and we create a folder. So we send some fucking folder to the folder channel. That's when we add one. So if you look at this go routines block of code, so this is the block of code, and we are adding it in the loop. We are adding it in the loop. So we pretty much add so many counts. So I think I probably need to put it in here, I think, in this block, because this is the block that kind of adds it, and when we're done we decrease it. Don't know why. What are we trying to achieve here, bro? Like, we are trying to track when this go routine is completed, right? So this go routine is complete when it's done executing all of its block of code. It does not start any other go routines. So let me just put it here on top of that, and then we have another go routine that doesn't do anything. So pretty much like we will end up, we kind of we add one task, and we increase the counter and we decrease the counter, so we pretty much end up with 0 by the time like this. So we want to add when we push it into, we want to add a counter when we push value to the folder channel. The only time we are done is when we process the channel. So here we receive a value from the folder channel. We start a go routine. we are processing the go routine. So uh yeah, like, so we take the full folder path, and we are trying to process it. So we want to decrease the counter when we are done processing that folder. So by the time it's done here, and we add another folder. Okay, this seems pretty good enough, right? What's wrong? Hmm. Okay, let's ask ChatGPT what's wrong. What's wrong? You have few concurrency bugs that can cause deadlocks and panics. Can block forever in main. So this line folder, we are pushing some value to the folder channel. I believe like we are doing that everywhere, like here. We are pushing some value to the folder channel. This can block. Why? So this runs uh, independently. We have also for loop. So there is nothing that should block. This coroutine sends to folder channel, but if nobody is currently receiving, it blocks. Meanwhile, your closing coroutine can reach wait before some add call. Okay. There is no add call, right? Assuming like these two coroutines like run independently, and before this coroutine can run, there is no add call. So let's just call, try to, let's just add, we're gonna add one and defer VG. Done. Let's see if this works. It kinda did something. It processed some files and end up with algorithms are asleep. So somehow we end up blocking. We end up with block. Can reach wait before some head count. That's the race. Wait group misuse. This is the biggest issue. You do closing function while other Go routines are still doing add one later. The docs explicitly say calls with a positive delta that occur when the counter is 0. Okay, what is this line of projects? It's called rules. Let's call this rule 1 or something. Calls with a positive delta that occur when the counter is 0 must calls with a positive delta that occur when the counter is 0 must happen before a wait. Okay. You're calling add concurrently with wait, which is invalid. So we're not supposed to call add concurrently with wait. So we actually need add before we even start this go routine. Okay. Sending on closed channel panning. Imagine wait group reaches 0, wait returns, channels get closed, another, okay, the boom, okay. Potential coroutine leak. This coroutine, so we have never closes anything and never signals completion. So we have a go routine that we are not tracking. So we have a, okay, where is it? Where's the go routine? We don't have that go routine. Where is it? For entry, range entry, never closes. So we have a go routine that loops over entries. Where is it? Okay, here. Okay, let's just remove this. Let's not, we don't want that go routine. We're not tracking this go routine. Wait a minute. We are, okay, we are not tracking this go routine. How are we supposed to track this go routine? Let's just add I don't know, let's try to add, for shits and giggles, 1, and let's just call done differ. Does this fix in any way? Okay, we already got a deadlock for some reason. So yeah, I think this is wrong. Never closes anything and never signals completion. So your program relies entirely on the wait group logic, which is currently broken. Unnecessary anonymous function. This is absolutely nothing. The reason we had that function is because we wrapped it in a go routine. So we're not using go routine, so we could remove it. All right. So I have fixed some stuff. The thing I fixed is this. We're not concurrently, we're not independently launching this go routine when we don't have a ad. That's pretty much what I fixed. Okay, I fixed some stuff. What's wrong now? You fixed one thing and introduced another cursed thing. Differ in main is wrong. You have, okay, the done won't run until main exits, but it's waiting for counter to hit 0. Since main hasn't exited, that differ done never runs, blocks forever. So this is wrong. Fuck. Okay, still calling add concurrently with wait. You still have while elsewhere. Still calling add concurrently with wait. Why this is wrong? Okay, wait a minute. Why is this wrong? I thought this was supposed to fix it. Inside process folder, and inside process folder, this is classic wait group race. The problem is that isn't that it sometimes works. The problem is that Godox say you're not allowed to do it. Root directory never gets a matching done. you do for the root, but there is no corresponding done for the root work. The deferred one in main is not tied to finishing the root scan. It happens when the whole program exists. Possible deadlock. Suppose videos contains folder 1, folder 2, file 1. The sender coroutine starts, sends a folder to the folder channel. This blocks until main receives, main receives and launches process folder. Then sender receives folder for some value in the folder. Now imagine a deep tree and one of the folder is trying. While no receiver is available, worker blocks. Since worker is blocked, done never executes. Therefore, wait never returns. Deadlock city. Mm, if two folders contain test, you will just see tests. You usually want the deeper issue is architectural. You're using folder, channel, and wait group to implement a work queue, but the wait group count is being modified by workers after wait has already started. Okay, this is some goofy thing. What does this mean? For a queue-based design, your usual pattern is workers read folders from folder channel, only one coroutine closes folder channel, use a work group to track active folder jobs. Okay, workers read folders from the folder channel, only one coroutine closes folder channel, use a wait group to track active folder jobs. When a folder is discovered, increment before enqueuing it. When a folder finishes processing, call done. Right now, you're halfway between recursive walker and a worker pool walker, which is why the synchronization is fighting you. So this is the solution, but I don't even understand this solution. Okay. File counter. Okay. What does this mean? It means you're breaking one of the assumptions sync wait group relies on. Think of wait group as a counter. Add one, counter one, add another one, counter two, done, counter one, done, counter zero. Wait waits until counter becomes zero. The important part is before you call wait, go expects all future work to already be accounted for. Your all future go. What does this mean, bro? Before you call wait, go expects all future work to be already be accounted for. What does this mean? Your code does this. Okay, I'm just closing files with channels. At this point, wait starts watching the counter, but later a worker discovers another folder. Okay, we discover folder. We add the folder. So you are increasing the counter after the has begun waiting. Imagine this timeline. Counter 1, wait starts, worker finishes, counter 0. Wait wakes up, now go thinks all work is finished and may proceed to close channel, but at the exact same time another routine discovers and one new folder. Now you have new work appeared after wait. Thought everything was done, that's the bug. A simple analogy: suppose a manager asks, tell me when all employees have left. You count Alice, Bob, Charlie, and start waiting. Then Bob, I stay while you're waiting. Your work is no longer valid. Wait group wants all the employees' work attempts counted before you start asking whether everyone has. Wait group wants all the employees counted before you start asking whether everyone has left. In directory working, this becomes tricky because you don't know all the folders ahead of time. Okay, in this the reason it's in directory working, this becomes tricky because you don't know all the folders ahead of time. You discover them dynamically. You don't know subfolder A exists until you scan folder 1. That's why queue-based crawls have to be very careful about when they call. Okay, they need to be very careful. You discover them dynamically, and when they call wait other and when they otherwise you get a situation wait all folders done. Actually, I found which is exactly what your code allows. So what's the solution when I try to find folders dynamically? The solution is the wait group should track folder jobs, not routines that happen to exist right now. So I usually use wait group to track go routines, but instead it wants me to track folder jobs. A common pattern looks like this. Root folder exists, okay? Then every worker does. Uh, this folder is finished. Discovered a new job. Wait starts after the initial root job is counted. Every newly discovered folder increments the count before it is put on the queue. The folders done happens only after that folder has been fully processed. This is actually safe because the counter never reaches 0 until there are truly no more folder jobs anywhere. And design is a worker pool. Main adds a folder to the channel. Workers uh, mm, far folder channel. This is classic concurrent file system crawler. However, there's a subtle thing that Go docs warn about calling add concurrently with wait when the counter might already be 0. So the real invariant is if counter is greater than 0, workers may add more work. If counter is equal, nobody may add work. The queue pattern above satisfies that because root starts with counter 1, every discovered folder increments before the current folder decrements. Therefore, the counter cannot accidentally hit 0 while more folders are still discoverable. Think of it like a relay race. Folder A processing, folders process B, add 1, folder A. Counter never reaches 0 between them. That's the key idea. The moment that counter reaches 0, you have proven that there are no folders left being processed and no folders left waiting in the queue. At that point, it's safe to close the channel and exit. So the Go docs warn about concurrently running add with the wait. So we call the add. So we are tracking folders. So this is the root folder, I think. And when we add, okay, and we call done, we add, I am tracking folders. What's wrong? You are almost tracking folders, but your counter never reaches 0. Look at the root folder. You added 1 for the root, but where is the matching done for the root folder? There isn't one. So the counter stays at 1. Then suppose there are 2 subfolders. Okay. Then both process folder finish. Okay, then both process folders finish. Counter 1 not 0. So waits forever. Another issue, your initial go routine is doing the root folder's work, but it never does uh, done when it finishes scanning the root. It should look conceptually like, otherwise the root job is never marked complete. There's also still a race, can start waiting immediately. Meanwhile, your root scanner is still doing. Add one for discovered folders. That is the thing I was talking about before. You're modifying the wait group after waiting has begun. Sometimes it works, sometimes it. Dark said don't do it. The clean fix actually. Add one, don't special case the root folder, treat it exactly like every other folder. Right, so we are special treating the root folder, so we need to do something about it. Right, so go process folder. Mm, mm, path, and then folder channel, file channel, and address of wait group. So let's get rid of this. So the reason it was not working is because this is essentially what this is doing the root channels work, root folders work. This is root folder. I'm not using the process folder function for it, but I'm also not marking it as complete. So it ends up, our program ends up with counter 1 because we never mark this as completed. Declared and not used entries. Where is it, bro? Right. We have no errors. That's cool. Okay, let's drop this in the V folder that doesn't contain anything. Dude, did this process all the files? That was really quick, bruh. Like, so we are printing. Okay, let me just create file count int So every time we get a file, we increment file count. After this, fmt println files file count file count. Okay, what's going on here? Why didn't the file count run? Hmm. Hmm. What's wrong? This is much closer. The main remaining problem is still this. While workers are doing inside process folder, why that's dangerous? Imagine counter is one, root folder is being processed, it reaches the end and is about to return. At nearly same time, the wait coroutine is doing, and another coroutine is trying for a newly discovered folder. Now you got add and wait racing. The Godox explicitly warn against this pattern. Another possible issue: you have unbuffered channels. Suppose the folder contains 1,000 files and 2,000 folders. Every send blocks until the main coroutine receives it, so your traversal is effectively serialized. Worker send file wait, main receive file, worker send next file wait. Not incorrect, just much less concurrent than it appears. You are ignoring if you hit access denied, you silently continue at least two if error return. So when we are reading a directory somewhere in the file process, I'm gonna just do this. The subtle bug nobody noticed. You send only so often work, but it still has a wait group usage pattern that the Go docs consider unsafe. That's the last major thing I'd fix. Also, if you run, the rest detector might start yelling at you about the wait group usage. That's a good sanity check. Uh, okay, okay, let me just run the race condition bullshit. Mm, mm, okay, we get the file count. Mm, so it's not about the it's not about the program bugs anymore. It's just this is kind of ends up printing um in the middle of all the logs. How do we get this to print at the end? Right now it should print at the end of our loop. The problem is that your loop may never exist because the channels never get closed, which goes back to wait group issue. A quick way to see if whether you are actually finishing is all folders done. If you never see all folders done, then wait group is stuck. Nope. If your goal is simply print ever, then print convert, then this is already correct. The only actually happen to debug add if n is entry dir found. If you see lots of found message but never enough done message, you got a folder count mismatch and wait. Okay, our crawler pretty much works. The reason like we did not get the output is because the terminal is just can't print like pretty much like we have 80 82,000 lines and the terminal can't print this amount of lines. So I pretty much stopped printing all the file names and I created a file that we can append text to it, and wherever I try to print wherever I try printing anything, I just append that line to this file. So I ended up with this huge lines of text. So there are currently 30 it's like 300,000 files. Okay, don't worry about the so let's run this on C drive. I'm not even like trying to like put files that I don't put folders that I don't want to crawl. Let's see if this how long it takes. It's just terminal is it's not our program is slow or anything, it's just the terminal can't keep up with it. Okay, it pretty much like crawled whole C drive, and we have one, I think 1 million and like almost 1.5 million regular files. So this is just finding directory and leaving directory. So if we divide this by 2, we get how many directories we have on the C drive. So we pretty much have like 500,000 directories on C drive. We'll take a look at the actual code again in another video. So for now, let's take a look at what's happening. So I'm gonna comment out my unnecessary like stuff. I have some stuff that need it. So okay, let's just keep it, but let's not talk about it. Okay, let's run this on documents. All right, so we got a path and we got 2 channels and we have a wait group. So the first problem is we are calling add 1 and we are calling wait. So it's a race. It's a race between these two. We are waiting and we are adding 1 simultaneously, like they're independently running. So it's a race. So the Go documents tell you not to do this. So the star of this show is process folder. This takes the full path and channels and wait and the wait group. So that's pretty much it. So we're tracking folders we want to process instead of Go routines. So every time, like every time we find a new folder, we add 1. So this is the process folder. It takes a folder and it takes a folder and it processes it. It's when it's done processing, um, we complete it. So when we find a directory, we add 1. So we have a root directory. So we found a root directories. That's why we have 1. So everything is done. Root directory finishes. Root directory finds 1 directory, adds it. It keeps on recursively doing this. Although this is not recursive, but we are like pretty much like pushing directory to the folder channel. So I have a for loop. here that when we get a folder in the folder channel, we call process folder again. That's pretty much it. This is so much faster than using the non-concurrent approach. All right, that's pretty much it.